Good day, math learners! Welcome to session 15, Definition of a Hyperbola. In this session, we will try to define a hyperbola and illustrate how this particular conic section looks like. Before we begin, do not forget to click subscribe and click the notification bell so that you get notified whenever I post new video lessons online. Let's begin! Same with an ellipse. A hyperbola is another conic section which most of you have not formally encountered before in your previous mathematics classes. The graph of a hyperbola consists of two unbounded branches which extends in opposite directions. The photo at the right is Museo Somaya Plaza Carso in Mexico City. This beautiful architecture resembles a hyperbola when viewed at some angles. But which part of this is the hyperbola? We will find it out later when we are through defining hyperbola. What is a hyperbola? A hyperbola is the locus of points in a plane whose distances from two fixed points differ by a certain constant. The points are called the foci of the hyperbola. Let us now try to illustrate how a hyperbola looks like based on the definition. Using GeoGebra Classic, let us try to illustrate how the graph of a hyperbola looks like. Let us try to click here, hyperbola, and select two foci and a point on our hyperbola. Let us say negative 3, 0 is one of the foci of our hyperbola. And another focus of our hyperbola is at 3, 0. Let us say this point here is a point on the hyperbola. This is point 3.4, 3. And so there we have it. This is how the graph of a hyperbola looks like. Based on the definition of a hyperbola, this point here is our f sub 1, one of our foci. It's a focus of the hyperbola. This another point here is also a focus of our hyperbola. This point is a vertex of our hyperbola, v sub 1. Let that point be v sub 1 and this point here be v sub 2. And this point is the center of our hyperbola at 0, 0. This point here is point P with coordinates x, y. And based on the definition, a hyperbola is the locus of points on a plane whose distances from two fixed points, which is our foci, have a common difference. So when we say common difference, it means that if we take this point P to f sub 1, so this segment here, if we take the distance of this and deduct that by the distance from P to f sub 2, so we have P to f sub 1 minus P to f sub 2. That would be equal to a particular constant. Let's say the constant is 2a. And if we identify another point, let's say this point here, and this point is point R with coordinates xy. So R to f sub 2 is that segment, and R to f sub 1 is also this segment. So we can say that because R is on the hyperbola, therefore R to f sub 1 minus R to f sub 2 is also equal to the same constant, 2a. And all the rest of the points that we can find here in our hyperbola has the same difference of its segments when connected to the two foci. So that's how a hyperbola is defined. This time, let us illustrate how a hyperbola looks like at a different orientation. The previous hyperbola shown to you is like horizontal. The opening of the hyperbola is going to the left and to the right. This time, I'll show you a hyperbola that opens upward and downwards. So let us select hyperbola here and identify our foci at, let's say, at 0, 3 and at 0, -3, and a point in our hyperbola, let's say this point. Alright, so the focus may also be located at the y-axis or on another area of the Cartesian coordinate system, and our hyperbola opens upward and downward. It opens in opposite direction, but it's going up and down. In the previous example, our hyperbola opens to the left and to the right. In this second illustration, we can see that our foci is already on the y-axis. In the first illustration, the foci were at the x-axis. Here, if we connect the two foci, the segment is going to be vertical, while in the first example, the segment connecting the two foci was horizontal. So in this illustration here, f sub 1, this is one of our foci. This is a focus of the hyperbola. This one is also another focus of the hyperbola, one of our two foci. And this is the center of our hyperbola at 0, 0. This point is a vertex of our hyperbola, and so is this point here. This is v sub 1 and this is v sub 2. And so this is how a hyperbola looks like, where the segment joining our two foci is vertical. And based on the definition, if this point here is point P with coordinates x, y, and if we take the distance from P to f sub 2, and the distance from P to f sub 1, the difference of these two segments is equal to a particular constant. And it would be equal when we have a point here. Let's say this is point R with coordinates x, y, and from R to f sub 1 and R to f sub 2. If we take the difference of these two segments, it would also be equal to the same constant. So, P to f sub 1 minus P to f sub 2 would be equal to a particular constant, and R to f sub 1 minus R to f sub 2 would also be equal to the same constant. So, unlike the ellipse, it's going to be an equal sum. Here in the hyperbola, it's equal difference. And just if you might be confused, P to f sub 1 seems to be a smaller segment compared to P to f sub 2. But remember, we are operating distances here, and distance is always positive. So when we do subtraction from here, we take its absolute value. So that would still be equal to 2a. Same with R to f sub 1 and R to f sub 2. If we take the absolute value here, it would also be equal to 2a. But we don't actually need to take the absolute value here for the second one, because R to f sub 1 is longer than R to f sub 2. I'm just putting the symbol here because P to f sub 1 is shorter than from P to f sub 2. That they have the same difference. There is a common difference, and we let that common difference be equal to 2a. So, going back to our illustration, let us try to identify now which portion of our illustration of our photo of Museo Sumaya Plaza Carso in Mexico City resembles that of a hyperbola. So, looking closely at the figure, this could be our hyperbola. Let me trace it. Okay, this and this one. Alright? So, isn't it beautiful? This is Museo Sumaya Plaza Carso in Mexico City. Before we end, let me emphasize this, that any of the branches of a hyperbola is not a parabola. It is a misconception that any of the branches of a hyperbola is a parabola, because hyperbolas and parabolas have very different features. That's it, math learners! I hope you have learned something today as we discussed about the first topic on our fourth conic section, the hyperbola. Stay safe always. Bye!